Loosely speaking, we can say that an edge is a rapid change in image intensity within a small window in the image. So let's take a look at why edges are really important in computer vision. Here's an example from Vic Nalva's book. On the left here, you see a photograph of a sculpture by Henry Moore, a famous sculptor. On the right, you see a sketch of this sculpture, which is made by an artist. And you can see here that just with a few strokes, the artist is able to convey a lot of information about the sculpture, the three-dimensional structure of the sculpture, some of the lighting effects like shading and highlights, and so on. So this is just to convey the point that edges, where you have rapid changes in brightness, are extremely important in terms of conveying or capturing visual information. So now let's take a look at some of the causes of edges. What are the physical phenomena in the real world that end up causing edges in images? One of them is depth discontinuity. So let's say you have one object which is behind another object. It's very likely that these two objects are going to be made of different materials, and therefore there's going to be a sudden change in brightness at the edge between these two objects, and that's called a depth discontinuity. For instance, the bottle here and the background. And then there is surface normal discontinuity. So you may have two surfaces that are made of the same material, but they happen to have different surface orientations. And therefore, they end up receiving different amounts of light from the light sources. And therefore, they end up having different brightnesses. And that causes a sudden change in brightness at the point that they meet. That's surface normal discontinuity. And then, of course, you have surface reflectance discontinuity. You have something with a marking. In this particular case, you have these letters written on the label right here, the dark letters. And there's a difference in the material used in the letter versus outside the letter, maybe different pigments. And that difference in material corresponds to difference in reflectance properties, and therefore you get a discontinuity in the brightness. And finally, of course, you have shadows or illumination discontinuities. Here you see the bottle casting a sharp shadow on the background, and therefore you have a sudden change in the amount of light falling on either side of the edge, and therefore a sudden change in brightness. So now how do these edges actually manifest in terms of intensity profiles in the image? You get all kinds of profiles. You might get the simple step function right here, or you can get a step edge with a gradient on either side, or you could get a linearly changing gradient here with a non-linear gradient on the other side, or a roof edge as shown here. And also when you look at lines, lines really are edges on two sides. So you have two edges here, a rising edge and a falling edge. But for our purposes, we have to pin down a model for the edge so that we can use this to then develop a theory of edge detection. So we're going to take the simplest of these models and use the step function shown here, the step edge. Now, it would be nice if edges appeared in images like this very clean step function shown here. That would make the problem of edge detection a lot easier. Unfortunately for us, they tend to look like this because images are noisy. And then there's the sampling that takes place in the image. There's also quantization and other effects. So edges can actually look quite a bit different from the ideal step function, but we need to be able to still robustly detect them. So here's what we would like our edge detector to do. We would like it to find the position of an edge. Position doesn't necessarily mean just find the pixel where the edge occurs. Sometimes we want to know with great accuracy where exactly the edge is, with sub-pixel accuracy. That is, where inside the pixel does the edge actually lie. We also want to know what the magnitude of the edge is, so that we can perhaps threshold it to decide for any given application whether this is an edge worthy of attention or not. And then we want to find the orientation of the edge in the image. And we want to be able to do all of this with very high detection rate. That is, we want to find an edge if it exists and not find an edge where it does not. We want to have low false positives and low false negatives. We obviously want to have very good localization, which is Find the edge exactly where it takes place, the position. And finally, resilience to noise.